Good evening, everybody. Mm. So I hope my voice is audible. Let's program some data structures today. In the last classes, we have completed until stacks and trees. Due to some copyright issues, I have deleted the streams. Now let's continue with trees today. So we'll be trying to code binary trees first. Actually, this is a really good prompt in ChatGPT. You can use if you want. So teach me something like teach me binary tree implementation in C, like you would teach it to a five year old. So you can use that as well. Then it will simplify most of the things, the complicated things for you. So you can have an analogy of things in your mind. So a binary tree is like a family tree. Okay, each node can be treated as a person. Each node can have two children at max, the left child and the right child. Okay. So first we let us write the algorithm before trying to write the actual code. Before that, let me just pop out the chart as well. Pop out the chart as well. My voice is okay. I think it can be a little bit louder. And also there is some noise in the background, so just accordingly. Right. So the standard library and standard input output are needed because we are allocating the memory dynamically. That's why we need the standard library. And then define node. You need data part and pointers for left and right childs. Right. And then you are actually going to write a create node function. Right, right. The create node is going to be new node data type, I see. All right. Okay, we can do that. Right. Returns new node. Takes value as parameter. Yeah, right. It is just a basic 4-line code. And then in the main function, right, root create node with the value of 1, left root of left, right. You can access the member of that structure. And again, since that is another node data type, you can use create node, and you can just print those root of data, root of left of data, root of right of data. Right, I have written a basic algorithm. Let us try to code without looking at algorithm. And if we have any problem somewhere, we can then look at that algorithm. And if we still didn't figure out the problem, then we can go to the code. For some reason, the enter is not working. What happened to this enter? Oh gosh. Yeah, there is. Okay, dude. The enter's not working. That is pretty awesome. Uh, Everything else is working except the enter. We got another enter here, but center is not working. Can we? Okay. Here the center is working. Right, the enter is working. Okay, there is no problem with the keyboard. That is a relief. Yeah, I'm pretty sure you can hear the background noises. Right. This center seems to be buggy. Right, I think that is a problem of my computer. Right, Right, it is working here as well. What? Yeah, let us try to open this. Where is this and binary tree? Is this one? Yeah, come on. Is it working in the VS Code? Okay, it is working. Gotta be the problem with the software, I assume. We will figure that out later. I don't think this is really a good time for me to stream because sure no one can hear my voice properly. I don't think this is really a good time for me to stream because sure no one can hear my voice properly. Can actually increase the sound by increasing the voice. This is really a good time for me to stream because sure no one can hear my voice properly. I'm watching a video instead watching a video. Can actually increase the sound by increasing the so if you put this thing at max, you can increase the input size as well. Okay. My voice properly. Is it any better watching a video instead watching a video? Can actually increase the sound by increasing the so if you put this thing at max, you can increase the input size as well. Okay. My voice properly. Okay. I'll let it be. Is it any better watching a video instead of watching a video? Can actually increase the sound by include a stereo to so if you put this thing at max, you can increase the input size as well. You can hear my voice properly. Okay, I'll let it be. Is it any better watching a video instead of watching a video? Can actually I think I should remove this include a stereo to so if you put this thing at max, you can increase the right. So what is the first thing? Struct node. All right. In data, struct node left, struct node right. Right. This is how you define a node, and after defining a node, what are you doing? You need to write a create function. Struct node create node is going to take value as a parameter. Struct node new node is equals to struct node star of ml of size of struct node. This will allocate the required memory for the new node, and new node of data is equals to value, right? New node of left is equals to null. New node of right is equals to null as well. And then we are supposed to return new node. That's it. Then this is the create node function. And yeah, I think we can write the display function. I mean, we can write the traversal later, but we are just demonstrating a normal tree here. So int main, let's struct node root. So we defined something called root. Root root is equals to create node. This is going to create a node with value 1, and root of left is equals to create node with value 2, and root of right is equals to create node with value 3, right? And then we are printing those. Printf root. Okay, you need to use format specifier here, right? Yeah. Root of data. This will print it out. And printf backslash n left child person b root of left of data. You can use like that as well, by the way. And right child can really see improvement in coding. If you do consistently every day, actually you can be good at coding. That's what I have seen in these 3 days actually. Return 0. This should work, I think. Wow, root 1, left child 2, right child 3. That is very basic program, but we got to start from there, right? Alright. Really love the background noises over here. Okay. So we have written the code. Wow. I mean, without even seeing the algorithm. Right. Traverse the tree. Okay, just write a traversal. Okay. This is a recursive function. Okay. You are calling function inside a condition. Okay. I think the next step is to write the traversals. Okay, write the traversals as the next step. Okay. I mean, what are we supposed to write that? Void type traversal takes root as input. If root is not equals to null, print the for pre-order actually. Print root of data, then call it pre-order root of left, then pre-order root of right. It is really as simple as that. And in the same way, we are trying to write the in order and post order, and we will call all of those functions instead of printing those in the main. Void pre-order struct node. Okay, let's call it root only. It doesn't matter. Right, so if root is not equals to null, I mean, that is like a recursive call. It needs to perform this action until the root is not null. Right, printf %t root data, and then you are going to pre-order root of left, because that is what the parameter is taking, and then pre-order root of right. That's it. And now you are trying to write the in order function, and same it will take the root. Right, if root is not equals to null, then for the in order you are supposed to first traverse the root of left, right? In order root of left. After that you will print f, right, and you will print the root of data. It is just a recursive call. This is like the base case, and then we will do the root of right. That's it. And then the void post order will take the same struct node root. If root is not equals to null, for post order you are actually doing the left and then right root. That's it. Post order root of left and then post order root of right, and then print of root of data. That's it. And then let's actually call this, instead of printing, reorder the root in order the root, first order the root. That's it. Okay. So you're actually supposed to add a backslash n. Yeah, let's do something like this. Yeah, but means right. And let's do the same in order to release. First order release. Okay, we got a semicolon. Right. 1 2 3 2 1 3 2 3 1. That is pretty neat. Okay. Create a node. Root is equals to null. Okay. Okay. So this is actually great. For some reason, this code is hurting my head. I think that is how the learning happens. Okay, so the problem that I'm having here is in the based logic. If you can have an empty position, if you want to find leave mode, and that was the child and oh, your current spot is empty. No, it is not empty. So this is a base case. That's a Right. I mean, all the tree logic is same. We have written without seeing once, so why cannot we write it twice? Alright, the chat is looking really empty here. If anyone's here, just drop a hi so that I know if someone else is watching the video as well. No, I don't think anyone's watching the video, but oh my god, this music is hurting me now. So no definition is the same. Create the same. So insert function, it will take root and value as parameters. If root is equals to null, and you are supposed to return a create node, value. We are going to create node with that value. Okay, if value is less than root of data, I mean it's not else if it's not else if here because it isn't a ladder. Can use as many simple ifs as you want. And that is the logic I was missing the entire first year. I mean, if you wrote an if, then I used to think like you cannot write another if down there. But this is a simple if, and I mean the root is equals to null condition is a simple if, and the value is less than root of data is another simple if, and that has another else if condition. That is a different case, but you can write as many if as you want, one below the another. That is not a wrong syntax. If value is less than root of data, then root of left. You are going to the root of left, and then you will insert on the root of left. That's it. Okay, root of left and value, just recursion, and say in the right, else if, and return root. I mean, you have understood pretty much what you are supposed to do now. Let's try to write the code without seeing. Let's save it. I mean, now I understood that I'm facing this problem because I didn't even start with coding in the first place. So BST. Save it BST, okay. Struct node to int data. Struct node left. Struct node right. Okay. And then we are going to create a function struct node create node. And what parameter does that take? Create node. It will take value as a parameter. Int value. Right? That is how it is. Struct node new node is equals to struct node star malloc size of struct node. Okay, this allocates the memory. New node of data is equals to value. New node of left is equals to null. I wrote the spelling of null wrong over there. New node of right is equals to null. Return new node. That's it. Okay, this is the create function. And then what are we going to do? We are going to write the insert function. Struct node insert. It will take two parameters. Struct node mm, does it take, let's say, root, and it will take int value, right? Since this is a local variable, this doesn't affect this. Don't worry. Okay, and the base case if root is equals to null, then we will be returning what? Then we will be returning create node with value. That's it. And then if value, the value we are supposed to insert is less than root of data, if the value is smaller, then we will go to the left subtree, right? Okay. If value is less than data, then okay, root of left is equals to insert. Then we are calling the function recursively. So at root, we get it. Right, we are traveling to the left. That's it, right? Insert. Right. Else if value is greater than root of data, we will be traveling to root of right is equals to insert root common value. And after that we will return the root. This is just a recursive function, a very basic recursion. And then void in order because it will give you the ascending order. Right in order. Okay, how do you? Oh gosh, how do you write the in order? Structure node root. Okay, first you are going to recursively call that in order root of left and then printf root of data and then in order root of right. Okay, the sounds are finally over. I think this is the in order. Then you have all the functions you need. Create node with the value of 10. Create node with the value of 5. Create node with the value of 15. If this is correct, it should be able to in the ascending order of the values, right? Okay, all right. You are not calling the uh, okay, let's say think you are supposed to use the create node function only once, right? Yeah. Root is equals to that will be stored as the root. Insert, then you will store it in the new root. Insert root 20. I think that is how the code is. Or you can directly call it. I think so because you have written another case for now as well. I don't know about this code. I think I have written it correctly. What is the name of this BST? Root, okay. Okay. Struct node root. How about that? Yeah, as I expected. Something is wrong with this code over here. Okay, wrong recursion. Infinite recursion. Stack overflow. Okay. Oh yeah, yeah, yeah. I mean, got it. Even if the root is not empty, it won't go deeper. It will just rotate over there. So you are supposed to go to the root of left. See if it is null, right? Root of right. And let's see if it is null. That is root not initialized in the main. Uh, can't you just write it like that? Why is it still the same? Okay, in order is missing base case. Oh yeah. So now I'm curious. Hmm. Okay, that is actually good. We had some understanding of the concepts. Right. Okay, someone finally came to the stream. I don't know if they are still in the stream or not. Mm, next one I will repeat in this is Venus level. Let's go with that as well. Right. Right node, right helper functions, right height, right create node function, right rotate. How are you going to yeah, right rotate? Get the balance factor. For some reason, this code is looking very little devilish for me now. Maybe it's because of the fact that I have written BST entries before. For the first time, I have seen this code straight out without doing any BST or trees. I was like, damn. I mean, how am I supposed to write a code this long? But now the flow is actually kind of looking great. Right, so it is 8 almost. I think we can be able to comprehend and write that code before 8:20 or 8:30. And then we will get into Beatrice. I mean, now I am able to write a 50 line of code by myself. Really, pardon me for the noises. I mean, I cannot do anything. Let's take a small break. Really, pardon me for the noises. So, can we have live analytics? Hmm, okay. So, can we have live analytics? Hmm, hey, actually, before going there, I need to see if we have any infrastructures lab, right? Yes. Okay, Horowitz's book was it's a good one, man. Surely implement a BST using linked list. We did this. Traversing of BST, we did that as well. Wow. It has table with collision resolution techniques. Yeah, we are supposed to do that, but that is not of requirement as of now. That's why we are not doing that. Cannot get access folders. Where is this one? There is this. I need to look at this labs too. Yes, I think those are the five subjects. What the data mining lab? Okay. What? Creation of database. Set up the group. Where did I say gaming here? Gamings. Yeah, that's it. So Balance is usually one. Uh, mhm. So, very, very small break. I'll take a small 15-minute break, guys, after the naval race. Now I have understood I haven't spoken like in the past 5 or 10 minutes. I was really thinking about this balance and rotations. Why you need math for programming. Yeah. Sadly, when you join the computer science, no one tells you that. So 20 minutes, 1 hour, 10 minutes, not so bad. I'm not supposed to say the analytics like this every minute. Oh, we hit 4 viewers. And now we are having 2 viewers. I don't know, is anyone here watching the stream? If you are just drop a hi or something, then it will be then entertaining for us as well. Just I will understand that somebody else is watching the stream. Yeah, anybody? No. Okay. Um, I'm supposed to write this code before taking a break, and if we are really able to write that code without seeing, then I can say this is a great accomplishment. Yeah, so what is the flow? You are writing the node, the structure, and then you are writing the helper functions. You are writing the max with the ternary operator. Okay. If A is greater than B, return A, else B. That's how you do it, okay? And then you write the height. So height is like yeah, because yeah, I forgot to say one more thing. In the node, you write data, you write left, you write right, and you write height as well. So okay, if the case is if n is equals to null, you are going to return 0 or you are going to return enough, right? So you're just accessing the member of the structure, that's it. And you are right rotating. Yeah, we just see how that right rotating works. Right. Just define y, x, and t2 and perform rotation and update the heights and return the new root. And same for the left rotation. And then you will write the get variance. Okay. Height of node of left minus height of node of right. Okay. You will perform the insert option. Okay. The in order we can write it the same one, right? So these things are not fitting in for some reason. Okay, for the get balance, you are writing the height function. Okay, that's what I'm thinking. Where are we using that height function? We are using that height function for the get balance. Okay, got it. Oh, and actually, so this is going to be the flow node, and then max, and then height, and then after that what you just create. Yeah, you are supposed to create, right? Okay, you will create a node and you will write the right rotate function and you will write the left rotate function. Right, initialize, rotate, update height. Okay, y of height and x of height you are updating. All of these are of node function by the way. And then you will write get balance. And then you will write insert. If node is null, return create. If okay, so this is a binary search. Okay. Okay, now I'm really trying to understand flow here. So if you write less than or equal to, then there will be duplicates. If you write greater than or equal to, then there will be duplicates. So if you can, but if you write the node, I mean, if you return the node, it will keep on rotating that recursion, I think. In the insert function, let's say you gave two same values, then will it infinitely? Yeah, it understood, man. So duplicates are ignored and recursion stops. Okay, once it with the else block, will the recursion start? Oh yeah. Yeah, I'm still trying to understand what how control statements work. Wow. Okay, then you will update the height and then you will get the balance. Wow, someone told the code will be written and understood before 8:20. It's 8:30 and I'm still trying to figure out how to write the code. Wow. If balance is greater than 1 and root is okay. Okay, so yeah, there will be obviously mistakes in the first dry run. But you know what? I gotta try. Just to create a node, then you write the max, then height, then create, right rotate, left rotate. Then you will write the get balance function, then you will insert. Yeah, in the insert, if one k is less than node of k, okay, you wrote key, you see. Node of left is equals to, yeah, insert node of left comma key, else if same, else return node, no duplicates, hashtag no duplicates. Okay, update height, node of height is equals to 1 plus max of node of left, comma node of right. Okay, get balance into balance is equals to get balance. Okay. Uh, if balance is greater than 1, that means the left value is higher and the node of key is less than node of left of key. That means it is right. The tree is like this. So right rotate. Balance greater than 1 and key is less than node of left of key. After that, return node in order main. You know what? If you think like this, you will think like this forever. Just go to action, man. Let's write it. I have understood. I will be staring at the screen and hitting my head for the next 30 minutes, but that is necessary. So, first you are writing a node, and this time I'm putting this thing algorithm right beside type dev struct node. That's it, right? Yeah. Okay. Int data struct node left struct node right int height, and you will say it node. Okay, you have written the node and int max. It will take two parameters int a comma int b. What are you going to return? You are writing the ternary operator a greater than b. If that's the case, then you will return a else b. Right. And then what is the height? Int height. What is the case here? Return. Okay, the height it is going to take the parameter. You are going to give the height of what? Node, right? Node x, node n. Okay, return if n is equals to null, we're going to return 0. Else you are going to return n of height. Slave temp struct node. Is this how you write it? Yeah, type def struct node, okay. N is equals to null, you will return 0 or you will return n of height. This thing is not working for some reason. I mean that pop up. And then you will write a create function. Node create. So what are the arguments this create function is going to take? Int value Yeah, this you have already written this, right? Now dual node is equals to strip node star of node. There is a struct node. Okay. New node of data is equals to value. Okay, it came to new node of left is equals to null. New node of right is equals to null. And new node of height. Initially, what are you putting the height? One, I think. Okay. You will write a new node. I mean, you will write a new node. And then you will write the right rotate function. Okay. And what are you going to right rotate? You will right rotate a node. Let's say y. So for rotating it right, it should be on the left. I have already drawn the diagram. Node x, node T2. Okay. X is equals to y of left, and T2 is equals to x of so right. Right. So now what are you doing? Okay. So you are replacing T2 with y. That means x of right will be y and y of left will be T2, and you will return the new root, that is x. Okay. And you will update the height before returning, you see. So x of right is equals to 1 plus max of height of x of left, comma height of x of right. In the same way, you will write y of right is equals to 1 plus max of height of y of left, comma height of y of right. Okay, you are updating the heights, and you are it on the node. Yeah, and you will write the left rotate function similarly. This time it will take node x instead of node y. So first, what are you doing? So yeah, struct node y is equals to x of right. When you write directly like this, struct node t2 is equals to y of left. Okay, and you are performing the rotation. So y of left is equals to x. Okay, x of right is equals to t2. Right. That's it, right? Yeah. And it's height is equals to 1 plus max of height of x of left comma height of x of right. Similarly, y of height is equals to 1 plus max of height of y of left comma height of y of right. Okay, you updated the heights and you written a new root that is you written y. And you will get the balance. తలుపుతీ తలుపుతీయమ్మా right, then you will get the get balance function. Then you write the get balance function. So you are getting the balance of node, right? Return height of node of left minus height of node of right. Is that how things are? Yeah. Okay, you took n here. Sorry. N of left minus n of right. You write get balance function and then you write node insert. What are you inserting? You are inserting a value. That is the single parameter you need, right? Do you need root as well? Okay. Do you need root for inserting? So is this probability? Yeah, you need root, dude. Oh God. Yeah, I mean, at least you came this long. You will write the insert and then yeah, before inserting that would be right. Creation will happen at insertion as the base case that is actually making sense. Before insert and then create the base case. The base case is consent. Create takes just the value to be inserted, whereas insert takes the root and to be inserted. Okay, okay, okay. Create and then insert. Um, okay, you're writing all of that in the insert function, right? I mean, it is just one single big function or rotate again, get balance. Yeah, in the insert itself, you will write that, I see. Now create. um, Did you write? Oh, wait, did you write a create function? Okay, already wrote the create function. That is how things are now, right? If root is equals to null, return create value. Mm. If value is less than root of left, root of left is equals to insert root of left and value, else if value is greater than, oh wait, this is true, root of data here, right? Yeah, what comparisons am I even making? Root of right is equals to insert root of right comma value, right? And if that's not the case, return true. That's it. Root of height is equals to 1 plus max of height of root of left height of root of right. Right? That should make sense. Then imbalance is equals to balance of root. I think to, to con- stop confusing ourselves, we are supposed to write then I need to learn some shortcuts. I mean, you can replace words easily, right? Instead of struggling. I got the balance. So we are performing rotations. If balance is greater than 1 and uh, okay, value is less than enough left of data. Value is less than enough left of data. Then you will be performing left rotate. Left rotate and receive balance is greater than 1 and value is greater than enough left of data. This would be an above rotation. Okay, you are supposed to return. This code is not making sense. Okay. Yeah, this is left rotate and need to return the right rotated value. So can you explain that on other cases? Mhm. Okay, this is the okay. So Kevlar, that means you need to left rotate, then right rotate. Okay, it is as simple as it. Left rotate. You just write that function, that's it. Okay. That gives a return value, right? Root of left is equals to left rotate and return right rotate and if balance is less than -1, that means it is right heavy and value is greater than enough right of data. That means it is right rotate. I mean, it is right heavy. That means you need to left rotate it. Left rotate it. Balance is less than -1 and value is less than enough right of data. Then you will add. Why did we write root here? And enough right is equals to right rotate and then return left rotate and that's it. What happened? Okay. So I just wrote an insert function. Inserting a get height. I see height won't change. And then return and yet in order. Let's write in order, right? Is it going to take any parameters? Yeah. If um and it's not equals to now in order and of left render present and day and of data in order and of right. That's good. The consume stack on it. And then finally the void main. So what are you going to do? Node root in I right in array is equals to let's take 10, 20, 30, 4, 5, 6. Yeah, that should work. I is equals to 0, I less than 6, I plus plus root is equals to insert root an array of I. That is going to be our driver code. And in order root, only God knows how many errors will be in this comma. Small errors like this, right? Like a comma, like an equals to this. What went wrong? Come on. I think we had this issue before. It's not an issue. Okay.